All right, in this session, we're going to examine Telnet and SSH with Wireshark. So we'll Telnet into the local host with Wireshark running and look at that capture, and then we'll SSH into the local host and review that capture and compare the two of them. And then we're going to create and verify hashes with Openssl. Both will be done on the CyberOps workstation, and we'll start then with the Telnet and SSH. So from the CyberOps workstation, open a terminal window. And we'll start Wireshark. Sudo Wireshark-GTK and hit enter and put in this analyst password. Click OK. We're going to capture on loopback 0, so highlight loopback 0, or click once on loopback 0 and then click Start. Now we'll open our terminal window, or another terminal window, and telnet to the local host. Log all the way in, analyst, and the password. And once you've logged all the way in, you can stop the capture. And then we want to go ahead and view it and see what we can learn from it. So let's filter on Telnet. So type Telnet into the filter, either click enter or apply, and then choose one of these Telnet packets to follow. So we'll just click on one, we'll right click, go down to follow TCP stream, and click on that. And then just see the information that comes up from that. The big thing to know are things we've talked about, and you've probably talked about or knew about at some point, was that Telnet isn't incredibly secure as a remote access technology simply because usernames and passwords are sent in clear text. The extra characters here are Telnet's echo features, so that you can see it on the screen. So when I typed in analyst, it echoed back to the screen. CyberOps or the password doesn't have the extra characters because we didn't see them on the screen. So we got in clear text the username and the password. And now let's go ahead and look at SSH. So let's close this up. And we got to exit out of we'll exit out of our Telnet session. And we'll go back and we're going to start a new stream. And we continue without saving. So when we start this again, we can clear that as well. Now let's go back to our terminal window and SSH into the local host. Yes. I just got to move my mouse out of the way. And password, CyberOps. Now that we've logged in, we can stop our capture again. Filter on SSH. And then follow the stream as well again. Now if we look at it, we've just verified what we already kind of knew. Even if we didn't know it before we are reading in the chapters, it was definitely in the chapters if we hadn't heard of it before. But SSH encrypted the information, therefore I don't see the username and password in clear text. So with Telnet, we were able to capture that login information. With SSH, we weren't able to capture the login information. So that's it for this part. I'm going to close all this up, and then we're going to go ahead and look at creating and verifying hashes with Openssl. Oh, let's probably close all these windows. We'll just start again, the new window. So hash functions are mathematical algorithms that take data in and generate a fixed size unique string of characters known as the hash. They're hard to reverse, hard to recover the data. The data created given just the hash or based on the hash alone. So we'll go through, and the first part is we're going to hash a text file. and then verify our hashes. So let's open a terminal window in our CyberOps workstation. Try to make it bigger. And we're going to change our directory to lab.support.files. Since we're in the home directory for analysts, it's already home analyst, we can just cd space lab.support.files, hit enter. What we're looking for is letter to grandma, or what we want to read is our letter to grandma. So let's cat letter to, and we've used this once before, letter to grandma.txt, and hit enter. And we can read our letter to grandma. So in the same terminal window now, we're going to go ahead and hash the text file. It's going to use MD5 as its hashing algorithm to generate the hash of the text file. And we're going to use OpenSSL to do it. So constantly having that cursor in the way, or that mouse in the way. Anyway, OpenSSL space MD5 space letter to grandma.txt, and we get our hash. So we use hash functions to verify the integrity of data, regardless of what that is. Hashes are calculated before and after transmission, then you can compare them. If the hashes don't match, then we know the data was modified. So we're going to change letter to grandma, recalculate the hash. So let's start with changing the letter. Nano letter to, I thought I capitalized it for a second, grandma.txt. So we open it up. I can't remember, what were we going to change in this one? Oh, we're going to change hi grandma to hi grandpa. So we just change it. And then once we've made our change, we hit Control X. Save the modified yes. Whoop. Sorry, I typed L instead of just Y. It asks about the file name. Just hit enter. So now we've made our small change. Then we're going to hash it again. So we just hit the up arrow. We're just going to hash the letter again after our one letter change. That's what I want you to notice, is that we changed one letter. OpenSSL space MD5 space letter to grandma.txt, hit enter. And what you notice is the hashes are very different. If you look at the two different ones we created. MD5 hashes are weak, so we want to use a more robust hashing algorithm that include SHA1 and 2 to generate. So we're going to go ahead and generate an SHA1 hash of the letter to grandma. So OpenSSL SHA1 letter to grandma.txt, and hit enter. And then after this, we're going to use, the next step then is to use MD5 sum and SHA1 sum to generate MD5 and SHA1 hash of the letter to grandma. So just a different tool. So we've used OpenSSL to do your MD5 and SHA1 hash. Now we're going to use MD5 SHA1 sum to generate hashes of the letter. All right, so MD5 sum letter to grandma.txt, and that works. And then we go ahead and we're going to hit the up arrow. We'll get rid of MD5 sum and do SHA1 sum letter to grandma, and hit enter. Now what you can notice here is we use two different tools to create the hash, but we use the same hashing algorithms, therefore we get the same hash. So if we go down to our Openssl MD5 hash, it's DCA1, and I won't read it all to you, but that's that hash. And if we go down then to our MD5 sum, or when we use, so this is our Openssl MD5, and then this is our MD5 sum hash, both using the same algorithm, just the different tool of Openssl versus MD5 sum. They give us the same hash. Both of them start, they are the same, but just so you don't have to read through the whole thing. DCA1, DCA1. Same thing with using Openssl with SHA-1 versus SHA-1 sum. Two different tools, but we're going to come up with the same hash. 08A835, so on, 08A835, so on. So different tools, but same algorithm, going to produce the same hash, as long as the algorithms are the same. And to note that it is suggested that we move on from SHA-1 and start using SHA-2 as our standard for hashing. Now, SHA-2 is a family of hashing algorithms, so just something to be aware of or to note. Now what we want to do is look at verifying our hashes. With the sample.img and sample.img SHA-256.sig, also downloaded with sample.img SHA-256.sig is a file containing the SHA-256 computed by the website. So first use the cat command to display the contents of the .sig file. So cat space sample .img underscore SHA 256.sig. And assuming I spelled everything correctly, which is usually my biggest issue, we can verify that, and this is what we were expecting to get. So now we want to use SHA-256 sum to calculate the SHA-256 hash of the sample.img file. So we just SHA-256 sum space sample, move my cursor again, .img. And we hit enter. And what we should have ended up with is the same hash as up here. So we kind of assume at this point then that sample.img was correctly downloaded. It wasn't modified in transmission because the hashes match. It's worth noting that there are better tools such as GPG to ensure the file has not been modified by any third parties.